Hello friends, welcome to Higher Math Central. Today we are going to discuss a question on real analysis, and the statement of the question is find the value of limit n tends to infinity within brackets 1 upon 1 plus n plus 1 upon 2 plus n and similar terms up to 1 upon n plus n. Now let us try to solve this. So this is clearly a summation, so we can write this summation uh, by uh, by using the summation sign, which is summation k varying from 1 to n, and the expression is 1 upon k plus n. Now you can verify that this is actually the sum, because first term is 1 upon 1 plus n, second term is 1 upon 2 plus n, and so on. Now this in this expression we can take 1 by n outside, and then we will get summation k 1 to n into 1 upon n into 1 upon k by n plus 1. Now why I have taken n outside common, I will tell you later the reason behind it. Now continue with me. Just now we can convert this Riemann sum into integration as follows. Now put k by n equal to z, then as n tends to infinity, the lower limit of the integration will become limit n tends to infinity k by n, where we have put k equal to 1 because the starting point is k equal to 1. Now similarly, so the value comes out to be 0. So now similarly we can uh, write we can find the upper limit of the integration as n tends to infinity, limit which is becomes limit n tends to infinity k by n, where k is equal to the final value that k assumes, which is n. So n by n becomes 1, so the value of the limit becomes 1. Now here the variable of integration is k. So when we write k by n equal to z, so in terms of variable of integration this becomes dk by n equal to dz when we differentiate. So the sum of this sum actually is equivalent to the integration 0 to 1 dz upon z plus 1. How it came, let us see. The upper limit and lower limit we have find out as 1 and 0, and the expression dk by n, so here it is 1 by n, and we can assume dk here as k is the variable running from 1 to n. So dk by n here becomes dz. The summation changes to the integration, and the upper limit and lower limit I have already told, and in the denominator we have put k by n equal to k by n has been uh, k by n we have put as z. So therefore the expression here becomes 1 upon z plus 1. So this is 1 dz upon z plus 1. So now we can easily solve this integration, and this integration is equal to log of z plus 1, where the limits, after applying limits, this is log of 1 plus 1 minus log of 1, which is equal to log 2. Now this is the answer. Now I want to tell you why I take 1 by n as common, because the reason was that I had to put k by n equal to z, so I needed some uh, n in the denominator, but this was not there, so I pull out the n common, so that I have k by n equal to z. Now to solve this integration, now we need to know when do we have to find the sum using integration. Now there is a very subtle trick that you have to follow. Now notice that the first term, that is a1, a1 is an expression containing n. Here a1 is equal to 1 upon 1 plus n. In general, when we have a sequence, the first term a1 is a constant and the variable n appears only in the nth term, that is the general term of the sequence. So whenever you find that the first term a1 is itself containing n, then you should realize that this is the this is the problem that requires use of integration. That is, this requires converting the Riemann sum into Riemann integration. Thank you very much.